Good. So, lightning talks. There are 7 people here for doing a lightning talk today. They are in this order. Kevin Noonan is here. Okay. So you are going to be the first one, right? After him, Claudio Galupo. Good. Second one, yeah. Bragi. Great. Dira. Good. Florian Gilcher. I don't know whether I pronounce it properly. Okay. Christian Kvalheim. Christian. Okay, yeah. And Tomasz Stachewicz, wise. Tomasz. It's here, Tomasz. Seems it's not. Okay, I will ask later if he has entered the room. Yeah? Are you Tomasz? Okay, good. So you are the 7th, the last one, lightning talk. Okay, so the format of the lightning talks is the following. The first speaker goes to the stage and prepares everything. It set up the laptop, connects everything, prepares the presentation. No, you are not the first one.
Oh, I thought you were calling me. Sorry.
Yeah, okay, yeah. Yeah, so, and when he's ready, we are going to start the time for his lightning talk with a Gong hick, like this. The talk has at most 5 minutes. 5 minutes, no mercy. 5 minutes, exactly. And at minute 4, there's another hit to warn or terrify that you have just 1 minute. So run and excuse your slides, okay? And at minute 5, there's going to be another hit that says, okay, that's done. I mean, okay. And next speaker is ready somewhere to just take over the stage and continue. That's the idea. Okay. So yeah, first speaker is Kevin Noonan, and please, Claudio, be ready somewhere.
Los 5 minutos van a empezar cuando toques, ¿verdad? Cuando toques van a empezar.
Sí, cuando tú estés listo,
Sí.
tú me dices, estoy
Okay,
listo.
gracias.
Entonces empezamos.
Okay. Muy bien, gracias. ¿Y ese micrófono? Good afternoon. This is a quick introduction to cloud computing. A definition of cloudware. Basically, it's outsourced virtualization. And that corresponds pretty closely to Berkeley's definition from a paper recently. And it's basically a virtual server running an outsourced server farm. The pyramid, this was devised about a year ago or so by Michael Sheen of GoGrid, and it basically divides into 3 layers: apps, platforms, and infrastructure. And Amazon's at the bottom. I'm going to concentrate on Amazon. The main players in the space are Google and Amazon. Now, there are many others. I'm going to concentrate on Amazon for this talk. Why would you possibly want to enter into this area? Because it's great for guerrilla development. If you have an idea, you want to get out to millions of users, it's costly. If you use Cloudware, you can scale up quickly and match your resources to your needs. Basically, you clone the virtual server and you pay for more resources. And in general, any outsourcing of your infrastructure. So Amazon Web Services, it's absolutely massive in its use. And these figures are a few months old. It's even more use now. There are hundreds of thousands of developers registered, not all of them using, obviously. And billions of objects. S3 is simple storage service. And they correspond to files. There are many different services. The most important 3 are the top 3. S3, basically an infinite file store. EBS is like a local hard disk for your server, which you attach dynamically. And EC2 is the Elastic Compute Cloud, basically a virtual server that you can rent by the hour or over long periods. Now, their pricing is in US dollars, even though these prices are actually nearly all the European prices. And you basically pay 18 cents dollar per gigabyte of storage. And EC2 costs 11 cents an hour, and that works out about $80 a month. But they have a great offer. If you're prepared to pay up front, pay $325 or $500, you can get a much cheaper price. So it works out a lot cheaper. If you divide that by the number of months, and you'll get a value per month, the cost. And that is a great offer for a dedicated server. That's for EC2. Okay, so $500 paid up front, and then depending where users are, pay $22 after that. By the way, I don't work for Amazon, I don't work for Google, I'm just telling you. Simple storage service, how to store your files. It's some very simple code you could run in an IRB interpreter in Ruby. And basically, you create a bucket. You connect to the service, create a bucket. They call them buckets in S3. And then you add a file to the bucket. Okay. A few wrapping up slides. If you want to get gems, you can get a Ruby AWS gem or an S3 gem. And you can Google on those terms, Introduction to Amazon for Ruby Developers. And you'll find a document on Amazon's site. So that's how you proceed with the Amazon Web Services. This is another offering from Joyent. If you're prepared to develop for Facebook, then if you have an active site with Facebook, they're prepared to give you a free slice on their cloud computing offering. But they have certain terms and conditions. You need to have a certain number of users active, or they will shut you down for a month or something. There are a lot of great papers out there and books. Particularly if you want to see an academic introduction to cloud computing from Berkeley, that bit.ly link up there. There's the book on AWS. Unfortunately, it's a little out of date. Some of the new services aren't covered. Some credits for my photos. Okay, Cloudware is the arsenal of freedom. It allows you to do a great deal, scale up your servers, reach many other users. That's the first Gong. I have another minute. Okay, there are my contact details. If you want to ask me about it, I'm really enthusiastic about this area. Like I say, I don't represent any of the companies involved, but it just has huge potential, and I urge you to try out cloud computing. Thank you very much.
Great. So, next speaker is Claudio, and after him, okay. Claudio now, and after that, Bragi.
Hello. Stai listo? Hi, my name is Claudio. I've almost finished my PhD in artificial intelligence in Barcelona, and I have developed a framework in Ruby on Rails that allows you to create a web radio online. And I want to present it here because I'm looking for people to collaborate, to just use it, play with it. So if you have any curiosity, just feel free to contact me. And with this framework, I have actually created a web radio, which has been running for the last year, and I will show you how it is, so to give you some curiosity. This is just the list of channels. Then for each channel, you have the current song that is playing, the upcoming songs, and you can either listen to the music by clicking on Listen Now button and your player opens up, or there is a flash player. Then the users can influence the music played. So the music is not pre-programmed, but depends on what you are rating. And there is also a chat for people to interact. So it's not like Last.fm that any person has one channel, but channels are public. Anyone can join a channel. And then there are also innovative features. So for instance, the same users can create channels. So if you want to define what music to listen, defining the genre, the tag, the year, you can do this. And new channels can be created by the same users. And there is also another thing that is the same listeners, if they want, they can contribute with their own music. So if you have a very large iTunes library and you wanted to make it available to other radio listeners, you can do it. You can share your personal music library. And in fact, in this case, you see that this song, for instance, comes from my library, and you can see the songs. And in fact, every user can also see which song this person is sharing. And there is also an administrative part just for the administrator to see all the channels, the users, the songs that are available. And this is a rough idea of the architecture. So most of the radio is in Ruby with Rails as the web interface. There is a large database in MySQL. And then the interesting part for a developer, I think it's the integration with this streaming part. So the streaming server is Icecast, and the streaming generator that takes the files, the audio files, like the MP3, and converts them to the audio signal is Liquid Soap, which is also open source in Occam. And summing up, I think that this is the first framework in Ruby on Rails that has been done to allow web radios. And I repeat, this has been already running for about a year. And it's interesting, first of all, for the users, but also for the developers, because it integrates, as I said, Icecast and Liquid Soap, and it also has some technical problems that I have solved in Ruby. For instance, as I've told you, users can create new channels, and each channel is a new audio stream. So in this sense, each channel is an independent process that is forked, and then all these processes are managed by Ruby. And then it has other features that I didn't explain here. For instance, it has a part of artificial intelligence to select the best music according to who is listening at the radio in that specific moment. So if you want to help, if you want to try it, right now this radio is running on internet. So if you want to try it, just ask me. It's not publicly available. And if you want to evaluate it, or if you want to contribute to the code, there is my email, and there is GitHub. The whole code is not there because I'm moving now from Subversion to Git, but there is a part about the evaluation and all the details that are there. So just feel free to contact with me. Thanks.
Good. So next speaker is Bragi, and to him, Dira.
Hi guys, now for something completely different. That's the topic of the presentation. I would like to talk about a problem that I've met several times already. I'm a very lazy developer, and this thing already hit me several times. Imagine that you want to call some kind of display method that is supposed to display a very expensive result of very expensive computation. But it wants to do that only if some other things happen. Basically, in every language I know of, and every language that is in common use, like Java or C++ or in Ruby, this is really hard to deal with. Basically, because always arguments are evaluated first. If I want to delay argument evaluation, I can do that in the Ruby way, which looks like this. As you might have noticed, there's only one slight change. Braces are replaced with curly braces. Basically, it's we're changing arguments to block call. This has several disadvantages. For example, if I want to put several arguments, I need to wrap everyone within a lambda, because Ruby doesn't take several blocks to one message. I'm lazy. I don't want to change my API for supporting things like this, or force user to use several lambdas. I want to write it like this, simply using normal braces. This doesn't work. Most languages you're aware of, except for functional languages. This happens because runtime evaluates arguments for you, and it always does before calling the proper method. So this is the proper order. And method, the display method, starts to run just below this horizontal line. Runtime evaluates computer-intensive arguments first. How I personally would like this to work is like this. It's completely different workflow. First, my method runs, then it decides if it wants to actually evaluate arguments or not, and then may do something more with evaluated arguments. There are several benefits for that. We can delay these time-consuming computations until the time that we think they are ready. There is one small change in the way of thinking. We're no longer receiving values of arguments, we're rather receiving a code that will eventually become values. It gives us several other advantages. For example, we can change this code that evaluates to some values eventually. And also, each argument becomes a potential block or potential list of messages, or basically code, and we can deal with that in a different manner. The problem is, if we implement some kind of language or whatever that supports that, we have to deal with this argument evaluation, well, basically in every method, and this is cumbersome. It's complex, and it shouldn't be done like that. It's actually easy to solve this problem. It's just complexity that we can automate, and we can provide two types of methods, basically. One, those that don't evaluate arguments and give us a really big power to do whatever we want with arguments. And another one that evaluates arguments by default. how this code can look like. This is example from working code, actually, that is available and maybe run in proper interpreter. This supports the first case. This one supports the second one when you specify arguments formally, and those are evaluated before the method is called. This has been brought to you by a JRuby developer called Olabini, and is available in a language called IOG. I think you should spend some time to get interested in that. Thank you.
Great. Now, Dira, good. And next speaker is going to be Florian. When you think you are ready, just tell me. No, it's just working. Just take it upside.
Okay, I'm ready. Gong. Thank you. I'm Irina Dumitrascu. I've been a developer for many years, but recently switched to Ruby, and I'm very happy about it. And what we'll talk about, it's a pet project that is called Vimish. And what it does is translates Vim comments to human understandable strings. What I mean, having an input string that works in Vim like we have here, that is very cryptical, very strange mumbo jumbo, that if you show to a beginner, he will be very amazed that this actually means something. If you feed this to Vimish, you'll get this very nice display in which each letter is interpreted in the right context, and then you get this explanation that is very easy, and maybe you can understand more of Vim. How did I do this? It's implemented in Ruby with Treetop, that is a library for defining parsers based on grammars. Grammars are the big, powerful brothers of regular expressions. They are more powerful, more flexible, and you can do a lot more things with them. What I have here on the screen is the grammar for this Vim parser. It's just the beginning. The beginning is simple. It says just that we can have normal mode commands or visual mode commands, motions or insert mode, and this can repeat many times. What Treetop does is takes this file and creates a parser for it. This parser will take a string and give that nice output that I've been there. So we are defining a Vim grammar. This was not supposed to happen. Never do presentations in Firefox. Okay, again. So, we have defined what is called a Vim language. It's more than that just rule that I presented, but it's not very complex. And this language defines a parser which understands Vim comments like 3, do, 3, 2, up, strange stuff. It will take this string, parse it, chop it, and tell you what each number means. What happens is that Treetop, we're going to go a bit meta here, Treetop has a grammar for the way you define with it. This is not working sometime. So it's like Treetop has a language that says to define a grammar, you have to say grammar, then a name. Then you have to say rule, a name for your rule, and then define it. And this is described in Treetop also, much like a Java compiler that is written in Java, a kind of bootstrapping. So this Treetop grammar will generate a parser that knows how to read grammars and give you like a tree of what was there in the grammar. It will tell you there was a grammar that is called Vim, and it contains a rule that was called main, and it has a choice between normal mode and command mode. Why am I telling you this? Because my last work on this pet project was to feed to this parser my Vim grammar and then use the result to generate random Vim comments. It's still not working perfectly, but it will like feed my grammar to this strange thing that is the definition of treetop, and will give some results like 2DD, 3-1 strange stuff. And I use that sometimes to like put new combinations of Vim commands that I didn't think of in my mind. I have some very crazy Italian friends that have a site that allows people to define grammars, and what they do is the same thing. They generate random things based on these grammars. So what is a grammar for generating names for metal bands, and okay, if you refresh the page, it will give you more. The guys that did the grammar really did a good thing. It's something like a lot of profanities here. And there is another word for generating manager talk, which is very, very good and sometimes makes sense, which frightens me. Okay, so I'm Dira on GitHub. You can find the project knowledge. And this is it. Thank you.
Okay. So next speaker is Florian, and after him, Christian Kvalheim.
Test, test. Test, okay. Yeah, I'm fine. Okay, I'm Florian Gilcher, and the topic of my talk is blues in dog. I'm a Ruby programmer for about 5 years now. I'm managing the largest German Ruby board together with some other people. I would say beginner problems are my problems, and one of the main problems is documentation. Most Ruby documentation is lacking. Just as a short indicator, half of is actually doing standard lib documentation that is not on the interpreter. One of the main examples is the mini-test documentation in Ruby 1.9. This is the mini-test documentation in Ruby 1.9. There is none. Why is this in standard lib? And it's why I hold this talk. Another example in core is fiber. There was no documentation for fiber until early this year, and it was in the Ruby repository for about 2 years. And the actual documentation is not explaining any interesting cases. And this is, I would say, the reason why no one really tested it. In January, you found like 2 rather obvious bugs. And of one, we weren't even sure whether it was a bug because it wasn't documented. There are positive examples. Rupert has a book about itself. Sinatra is quite okay as well. And Rails, yeah, they're okay as well. I'm not opposed to just releasing code without documentation if it's just some quick hack. But there are 3 misconceptions that you usually hear in Ruby. First of all, we've got no documentation, but look at the specs. Sorry, specs are not documentations. A good documentation shows intention and context in which the class operates. A good spec exactly defines how this class works. The nice thing is, if you have documentation referring to your specs, you're great. Second, read the code. It's pretty clear. Usually, no. Ruby has a personal style. I have to adapt to the style of the one who wrote the code. I'm okay with that. Beginners are not. And it always requires jumping to internals. So if I just want to skim the surface, I know this method does what I want, but I want to know how exactly I have to use it.
Why should I care about the internals? That's the reason why I have an interface. And I have other stuff to do than read code all day. I want to write it as well. The third misconception is dynamic code. You cannot document generated methods. That's not really true, especially Yard, the alternative documentation generator, has pretty good facilities to do that. And as a punchline, they're not documented. So the advantage of a good documentation is it makes those features visible, clearly. Second, it makes it easier for other users to adopt your library, writing fixes instead of rolling its own. It makes it easier to write a test. If you know what this method should be doing, you know what you should test. And as Matt said today, it contributes to a better Ruby more than another fancy testing framework. Thank you.
Okay, now Christian, and after him, the last lightning talk today, which is from Tomasz.
Okay. Yeah. Yeah. Okay, so my name is Christian Amor Kvalheim, and you can see the Twitter details in my email right there. No more to say about that. I'm going to just address a little bit of the issue around that Matsumoto talked about earlier today, which is about Moore's Law. Moore's Law is broken, like it broke, I think, this year. It's going to keep getting broken. Today we're going to get less raw gigahertz, like the current processors of the day actually are slower than the Pentiums of yesterday. You're going to get more cores. Today we got 8 cores. Next year we're going to have 16, and in 2011 we're going to have 32, and I don't think it's going to stop there. So that's one of the main issues we're going to face forward, going forward as developers. OO language problems is one of the issues that I'm kind of struggling with. The idea of state in programming languages is problematic when you get to multiple cores, because you have multiple problems around locks, race conditions, and efficient distribution of the workload across multiple CPU cores. Another issue is also threads. Operating system threads are usually based around the concept of segmentation, which is based around allocating a certain amount of memory per thread, which limits the natural ability of threads in a system to what memory you have installed in the base. Typical thing is about 64K per thread. And the cost of inter-process communication goes up exponentially as you actually add more threads. Functional languages, okay, so I know there's been a whole big flame fest around this whole Scala Ruby thing going on lately, but I really think it's worth having a look at it. First of all, they have a couple of aspects that you're not used to when you're doing object-oriented programming, which is they're usually stateless, and or very close to, actually. They also have different concurrency models, like Erlang has a specific one, Scala uses the Java concurrency model, Haskell has his own, and OCaml has his own. So there are different philosophies on how to approach concurrency. Like, I'm not going to put it between two chairs, but I probably fall more into the Erlang camp of these languages, but it's definitely worth having a look of the different ways of doing it. Now, why? Well, keep in mind that the lessons you get from learning a functional programming language is something that you can take back to your own object-oriented programs in Ruby to help you write code that is more concurrent safe and can be executed more easily across multiple cores. It also helps you change your code habits. You write your code a little bit differently just to ensure that you don't run into those issues. And one of the things, obviously, is that we need some better support in the virtual machines, especially like Ruby, to be able to hook into these kind of functionalities more easily from the language. Another thing is worth investigating is the actor model. There's a project which is Revactor Euruko2009.org. That's for Ruby 1.9. That lets you play around with the concepts that are used in languages like Erlang. And finally, be a hippie, save the world. Like, use your computer more efficiently. Make sure all your cores are maxed out when you're running your computers. And you can save a panda, or you cannot. That's it.
Okay, Tomasz. Good.
I'm using Linux, so it's going to take me like 3 times of what the Apple takes. Yeah, okay, just recompile the kernel for the display. Okay, cool. Okay, bring it on. I haven't checked the mic. Okay, hello, my name is Tomasz Stachewicz. I'm going to have a bigger talk too, but this mic obviously doesn't want to cooperate. I'm going to have a lightning talk about Jekyll, the sane blogging engine. I mean,
Try this one, okay?
does this one work? Okay. So yeah, everything's going to be sane now, right? So this is actually a piece of from the TV series Jekyll and Hyde. So we're going to talk about the really sane and trustworthy blogging engine. Why Jekyll? Well, mostly because it's written in Ruby, so it's cool, right? And we can hack on it. It has a very small, compact code base, so there's the guy changing into what I'm going to change if it's going to stop working again. Jekyll is also cool because it's a static site generator, so you get all a bunch of HTML, so you can put it on any crappy shared hosting you find, and it's going to work. And it actually has it's aimed at right the static pages with the DRI, but it has a full-fledged blogging engine, so it has liquid templates. It has tags, it has categories, you can use HTML or Markdown or text style. So why you should use Jekyll? Because Jekyll is very dry. Every file has a YAML header with configuration and variables to use it, and then it's parsed with a YAML parser, then it's parsed with a liquid parser, then it's parsed with a proper parser for a given markup. It has layouts, so you don't have to repeat all this boilerplate header code everywhere. It can be extensible. It's very scalable and light, like in static HTML, scalable and light. You can't get better than that, actually. And if you have to have comments, like if you have to make sure that someone's really reading what you write, I do, you can set up a Disqus account, which uses some magic JavaScript to attach itself and hosts your comments. So these guys looks nice. So let's see some Jekyll in action. I haven't had time to prepare any specific code, so let's just see Jekyll of my site, right? So let's see the main site, the index.html. As you can see, it has a pretty compact amount of code. It has the YAML header, which defines the layout, title, which is going to then be used in liquid template, small liquid template that just iterating around the blog posts, and that's it. That's all the magic. So where's the rest of the HTML? It's in the layout. And here's the layout, which also uses some liquid templates, uses variables passed by the sites, and has all the magical stuff here. This is content. If you use Liquid, which is a very crappy templating engine, if you have to ask me, but nonetheless, it's very, very easy to learn it. Okay, any other magic? This is HTML, but you can write in textile. And you're not limited to only writing your posts in textile. You can write any page in textile, and it's going to be converted to HTML. Yeah, I'm learning Vim, so thanks for the helping grammar. You can write in textile, and it's going to convert it to HTML. So I think that's enough for a presentation. So you can see it live on my website. It's on Jekyll. And grab Jekyll from GitHub. Thank you.
Okay, so that's it.